90% of DevOps engineers stop at deployment successful, but they never check if the app is actually reachable. If you ever trusted a green pipeline without testing it, this episode is for you. Because today we are going to debug a real issue using AI. But before we start, subscribe if you want real DevOps debugging, not tutorials. And comment CI/CD. I want to see who is actually building pipelines. Now, in the last episode, we deployed the application, but we never tested it. Let me jump into the terminal and let's do the testing now. Curl space http colon slash slash localhost colon port 3007. See, this is the problem. Application is deployed, but the endpoint is refusing the connection. So the real question is not whether Kubernetes accepted the YAML, but whether users can actually reach the application. Let's test that. kubectl get pods. I see the pod is running. Now let's check the service real quick. And I see services, cluster IP and the node port. Pods are running, service exists, but that does not mean it's reachable. Let's quickly look at the pipeline now. So here we have AI debugging folder. In this folder, I have the same exact application which we were using in the previous episodes, and I created a new YAML file. If you see here, we have a new YAML file with 06 AI debugging path, and followed by, in this episode we are trying to create the cluster. Okay, in the previous episode we did not create any cluster. If you remember, I'll show that real quick. So we did not create any cluster. In this episode we are trying to create the cluster, and then one more important step here, verifying the endpoint. This was also missing in our previous episode. Without environment setup, nothing works. And without verification, you can deploy a broken system. Now let's try to describe the deployment. For that, I'm going to run kubectl describe deployment. If you look at the deployment, here it clearly shows one available. Followed by, here we have the image name correct and port is 5000. This looks fine. Then let's look at the service. For service, I'm going to run kubectl describe service. Enter. If you look carefully, node port 3007 is exposed. And port 80, target port 5000 also looks correct. Finally, we are going to check the endpoints. For that, I'm going to run kubectl endpoints production service, and look here, port 5000 and the IP address endpoint. This looks fine. So let's recap it once again. Deployment is running, endpoints exist. Still we see port 3007 failed to connect. Now let's jump back to the application code. Kubernetes side debugging is over now. I'm going to jump back to the application code and look at the application code. This application listens on 5000. That means it is matching our deployment. Service is also matching. So the issue is not the application here. It's definitely somewhere else. This is where environment matters a lot. I'm using kind and kind runs Kubernetes inside Docker containers. So node port is not automatically exposed to localhost, which means the application exists, but the host cannot reach it. The pod can be healthy, the service can exist, and the endpoint can still fail from the VM if the cluster is not exposing the port correctly. One thing was missing in the previous episode was actual cluster creation step. We were applying Kubernetes manifest, but we were not making the cluster setup part of the full pipeline story. That matters because if the cluster was created in the wrong way, the node port will not be reachable from the VM, even if the deployment itself succeeds. This is the point where I check if the cluster exists. For this video, I want to show that cluster creation is not something we should assume silently. It is part of the setup, just like the deployment and service. Let's check that. I can see this cluster is running right now. I am going to delete the cluster now. kubectl delete cluster hyphen name k8's deployment. Enter. I am deleting the cluster because if we recreate it, the networking is guaranteed to match what our configuration has. So now let's jump back to our application. Application is very simple. It listens on port 5000, which is correct for container. The deployment has port 5000 and and the service target port is 5000. So the application code is not the issue here. This is important because in debugging, we want to avoid guessing. We isolate layers one by one. Node port exposes port on each node in the cluster. In many setups, that means you can reach the application through the node IP and the node port. But this is where the environment matters. I am using Kind, and Kind runs Kubernetes nodes inside Docker containers. That means a node port is not always automatically reachable from localhost unless I explicitly map the port from the Kind container to the VM host. Now I'm going to ask AI for help, but I'm not going to ask any random question. I want to give it enough context so it can reason about the actual setup. So this would be my question. I deployed a Kubernetes app using Kind inside a VM. Here's my setup: deployment name, service type, service port, target port, node port, and then say the application listens on port 5000 inside the container. The pod is running and healthy. I am running the curl command from the same VM. When I run this, I get this error. What is the most likely cause and how do I fix it in Kind? Please answer in a short, practical way and tell me the exact Kubernetes or Kind configuration I should change. Press enter. So the key insight here, this issue is not with the Flask application. It's not with Kubernetes either. It's specific to Kind's networking model. Because Kind runs Kubernetes nodes inside Docker containers, the node port is actually exposed inside that container network, not directly on the local host. So even though I see port 3000 in the service, that port is not actually open on my VM, which means Kubernetes is working correctly, but my machine still cannot reach it. So the fix is not in the deployment or service, the fix is in how the kind cluster is created. I need to explicitly map that node port from the kind container to my VM using extra port mappings in this kind configuration. Now let's try to create kind config.yaml. Jump back to our Visual Studio Code, and I'm going to create that in this particular folder, kind config.yaml, and copy this kind cluster and paste it here. So we added the kind config.yaml, followed by we are going to jump back to our pipeline, and in the pipeline here we are using kind create cluster and the name of the cluster, followed by we are going to update this line with the config kind config.yaml so that it actually uses this configuration while the creation step. Save this file. I'm going to add all of these changes real quick. Git commit -m, add AI debugging episode, git push. So the pipeline is running. Let me look at the pipeline, and the pipeline is failing. Kind create cluster config, yes. Fail to create cluster, error reading file, no such file or directory. Let me jump back. I know what exactly the problem is here. So the problem is k8 slash kind config.yaml. This is the problem. So if you see k8's deployment, k8's slash kind config.yaml. Let me push that real quick. Git add, git commit -m, update pipeline step. I need to save the file. Git add, git commit, and git push. Now let's jump back to the pipeline. And in the pipeline, I'm going to refresh this real quick. This will not run because we did not change anything in the exact same folder. So I'm going to run this manually. And let's see the output now. So build a test deploy. It is trying to create the cluster now. Kind create cluster. This step is running fine. Once again, cluster got created. Image got loaded successfully. Then deployment is also success, but verification failed. But verification failed. Let's jump back to our virtual machine and try to run this command and see what exactly is happening. Application is running. That means it works. So there is some problem with the pipeline itself. Let me jump back to the pipeline. And if you remember, we are trying to verify the application endpoint and there is no wait time at all. So we are going to fix that real quick, and I'm going to replace this particular step. Wait for application to reachable. We are using a simple for loop and we are trying to wait and sleep as well here for 5 seconds so that application is reachable and the pipeline is not failing. I'm going to save this real quick and run this once again. Git commit -m, update test step, and git push. Now we have a green pipeline. Setup job, creating the kind cluster, building the Docker image, loading the image, deploying it to Kubernetes, waiting for deployment, and finally the application is running. The pipeline is green and we can trust this pipeline now because we have this curl test. Let's try it on the virtual machine itself once again. Application is working. Everything works. The same URL that failed before is reachable from the VM and also from the pipeline, which proves the problem was the port exposure and not the application. That is exactly the kind of issue AI helps with. It did not deploy the application for me, but it helped me focus on real root cause much faster. The very big lesson
Application is
here
running
is
now.
that deployment success does not always mean external access works. Kubernetes can be perfectly healthy and still not be reachable from your VM if the cluster networking is wrong. AI was useful here, but it helped us narrow the problem quickly. Instead of guessing, we checked service, pod, ports, and kind configuration. That is the value of AI in debugging. Not replacing understanding, but speeding up the path to the right explanation. And for production, I would not use kind the same way. Kind is great for local demos, but real production usually uses a managed cluster, a real node pool, and an ingress or load balancer instead of local host node port testing. That wraps up our CI/CD series. We started with a basic pipeline, built it step by step, deployed to Kubernetes, and then used AI to debug a real world networking issue. In the next series, we are going to switch gears and move into shell scripting, where we will build the automation skills that supports everything we have done here. Thank you for following along, and I'll see you in the next series.